Hello, I'm going to illustrate a Matlab script that will allow you to repeatedly collect data, and then if you wish, stop and analyze it. So I'm going to start this script here. I'm being prompted for the length of the sample. I'm going to use 3 seconds instead of 2. The default is 2. And the central value is 261. We'll stay with that for the time being. Okay, every time it beeps up here and the red light comes on, it's recording, and it'll plot out the result of the recording. It is a trip point, and since I'm speaking at a low voice, it's not acknowledging any recordings. If I go over to the piano now and strike a key, we should get a recording. Okay, there's my recording. See, I've got a trace of the amplitude versus the time up here. It's 3 seconds worth. The elapsed time took 4.2 seconds because there's some overhead involved in gathering the data and calculating the spectrum and all that. Down here is the spectrum. And there's my fundamental. Here's my for a second partial, and so forth. I'm going up to 1,000 hertz. I can change that. While I'm talking, we're still trying to collect over here, but because I'm talking in the soft voice, it's not doing any new collection. Let's do another one before we leave here. Okay, here's another one. This time I didn't catch it exactly like before, but you can see over here that there's the beginning of the trace, and then the full 3 seconds wasn't used, so I actually padded the end of it with zeros. It's the same looking spectrum. Let's stop it and do some things with it. Okay, here's some options. I can change the frequency that I plot to here. I can continue collecting if I wanted to center it about a frequency using the fine grid line spectrum. I can switch back to the full range here. I can actually do a fine grid line spectrum on this collected data right here, which I'm going to do. I can save data if I wish to. If I like the data, I can save it. Okay, let's do the fine grid. Okay, let's see. 261 will be good because that was C4 that I struck. 50-cent spread will be, that'd be okay. Okay, here's the fine grid line spectrum. I've calculated the line spectrum over a spread of 50 cents, or in this case plus or minus about 4 hertz, but I'm calculating 1,000 frequency points, so it's much higher resolution than I would get if I used Fourier transform. You can see this peak here is about 2 cents flat of the theoretical fundamental. Down here it's about 3/10 of a hertz. Let's see. Yeah, about that. 3/10 of a hertz flat. Okay, let's go back. I can continue now. If I go back to my graph, press go, and press continue. It's recording. Now let's see. Let's do something like an interval this time. I'm going to strike C3 and E4 together. Okay, now you can see I've got down here, this should be the C3 fundamental. Here should be the first partial of C3. here at 320, this is E4. That should be the third partial of C3. This should be the fourth partial over here. And then over here should be the coincident partial. In other words, we got the fifth partial of C2, and then we've also got the second partial of E4. Alright, now this will be good. So let's stop it and do a fine grid, and let's look around this area here. So I'm going to say 660. Okay, and prompt it for the center, which I'll call 660, and 50 cents will be good. Okay, so you see I got the main peak here at the fifth partial of C2, and then I have a small one here at the second partial of, actually this could be the other way around. This could be the second partial of E3, and this could be the fifth partial of C2. I think that makes more sense. The point is they're separated. There's a little bit of a beating going on. If you listen carefully, I can't really hear it myself. But for example, we've got a difference here of about 14 cents. Yeah. And then over here we've got a difference of about five and a half, because there's a little bit over here. Yeah. So about 5.5 hertz difference. So this thing should be beating at around 5 times a second, if in fact you could hear it. Okay, that shows how this thing works, and I could save the data now. Let's just do that for the heck of it. I'm going to save it in the a place for book files, and I'm going to call it dummy, and it's done, and I'm going to quit, and I can go over here to dummy. There's my mat file. So this hopefully illustrates a simple script you can use to play games with your piano. Thanks for watching and listening.